Today we're going to talk about inverse relations and functions, the very last section in this chapter. So we're going to be having our test sometime this week. And so first of all, what I want you to do is I want you to look at Table A and Table B. And I want you to compare the two and tell me what you notice. I want you to compare Table A to Table B here. Tell me what you notice.
They're switched.
What are switched?
The tops and the bottoms.
The tops and the bottoms. So basically, this is up here, and this is down here. This is an example of an inverse relation because what it's done is it's interchanged the two. And so we're going to look at quite a few inverse relations. And so here, you're going to notice that I have the relation y equals x squared minus 4. Now, if I had an inverse relation, what can you tell me about the x's and the y's? They're switched around. So basically, what's going to be a value of x?
5.
5. What's going to be another value?
-2 or 0.
0, -3, -4, -3, 0, and 5. What are going to be my values of y?
-3, -2, -1.
Right. So if you notice, the x and the y's interchange. And so now what we're going to do is we're going to look at graphically what happens when we have an inverse relation. And so if I look here graphically, first of all, the first relation, x squared minus 4. What can you tell me about x squared minus 4? What is that? X squared is what? Parabola that opens up. So the parabola that opens up, so this here correlates to the blue
How do we know it opens up again?
because the x squared is positive.
Oh, okay.
Oh, yeah.
That correlates to the blue. What does the inverse correlate to? What do you think?
The green?
The green.
Yeah.
And so the red, if you notice that red, is kind of like a reflection line. And so if I have a function that's an inverse relation, it's actually reflected along that red line. What type of graph is that red line?
That is just an x equals y.
X equals y, that is otherwise known as what type of function? The identity function. Okay, so in order to have an inverse, you have to be able to pass the horizontal line test. So what that means is you have a function, if you can pass the horizontal line similar to the vertical line test, but horizontally, if I can pass that throughout the graph and it only touches it once, an inverse will exist. So before I start any of the problems, I have to see if it passes the horizontal line test. Okay. So now, here we go. It says graph each function and apply the horizontal line test to determine whether its inverse function exists. So I want you to graph f of x equals absolute value of x minus 1.
I handed it in.
Okay, graph y equals the absolute value of x minus 1. What can you tell me about the graph?
To be.
It's an absolute value. Where's the tip of the absolute value?
What is that one?
1. Okay,
Yeah.
so this is what you should get when you graph. You should get something that looks like this. So now we're going to see if an inverse function exists. In order for an inverse function to exist, I need to pass a horizontal line through that graph. And it can only touch one point at any given time. So now in looking at that, it's not going to work because if I write a horizontal line just even right here, I've got 2 points. So the horizontal line test fails. Since the horizontal line tests, there is no inverse function. Yep. An inverse function does not exist. Now here's a little tidbit. Eventually, okay, later on in the lesson today, we're going to learn about restricting the domain so that we could have an inverse function. So for example, if I look at this graph real quick, I want you to think about, is there a part of the graph in which that would pass the horizontal line test?
Yeah,
Yes.
the first point.
Yeah.
X,
So I could cut off the graph right here and just look at either the right portion or the left portion. And that would pass the horizontal line test, wouldn't it?
Yeah.
That's
Yeah.
cheating.
If I basically got rid of this part of the graph,
Yeah.
Why would you do that? Okay, we'll talk about that, but that's called restricting the domain. That's where we're gonna be going. Let's look at the next one. Let's graph y of x, or g of x equals x cubed. So x cubed minus 6x squared plus 12x minus 8. Okay? Now, what does your graph look like?
That's
Squiggle, yep. And where does it kind of look like it crosses?
I'd take 3.
Between 2 and 3?
Yeah.
So it looks something like this. Is that going to pass the horizontal line test?
Yes.
Yeah.
Yes, so we know that an inverse function exists. Okay, so that's the very first step. The very first step is you need to graph, see if it passes the horizontal line test. So now we're going to talk about a one-to-one function. You might have heard this term before, but a one-to-one function is basically nothing more than a function that passes the horizontal line test. Okay. Now, what does one-to-one mean? One-to-one means what's written here in purple. Because that was always kind of something that when I was in your shoes, I never quite understood what one-to-one meant. And this is basically what it means. Every one x value has exactly one y value. It's 1x to 1y. Every one y has exactly
Is that
one
like
x.
the table thing with the x and the y's?
Yeah,
If there's
yeah.
too many on one, you
Right.
can't do it.
Yep, that's exactly right. And so basically think about that way. When you hear one-to-one, 1x to 1y, or you can change those around. Okay? But it means on the table there's only going to be exactly one arrow going from the left to the right. And so that's pretty important up here in purple. It's important you understand a one-to-one function, 1x for every 1y. Now, every one-to-one function will have an inverse function. What you see here is the notation for an inverse function. That does not mean the negative 1 power. That exponent here of negative 1 means inverse. So whenever we hear inverse function, that's f to the negative 1. Now here's something a little important too here in the green. The domain of f equals the range of f inverse. And that should make sense, because when we looked at the tables on the very first page, remember how they switched? That's exactly what this is stated in green. So the domain of my original function will equal the range of my inverse. The range of my original function will equal the domain of the inverse. And that's exactly what we looked at on the very first page. So that's kind of some important things that we're going to be talking about today. Now we're going to look at some examples. So let's go ahead and see what we got. Okay, finding an inverse function. You don't need to write these steps down. Okay, we're going to go through these steps in an example. But basically, first step, we got to determine whether it has an inverse by checking to see if it's one-to-one. So very first step, we got to see if it passes the horizontal line test. If it doesn't pass the horizontal line test, you're done. You can't find the inverse. Okay, in the equation for f of x, we're going to replace f of x with y, and then we're going to interchange x and y. Step 3, we're going to solve for y and then replace y with f inverse x in the new equation. We're going to state any restrictions on the domain of f inverse, and then we'll go on to show that the domain of f is equal to the range of f inverse, okay, and so on. So here we go. Very first step, this is what you're going to be doing today. Determine whether f of x has an inverse function. If it does, find the inverse and state any restrictions on its domain. Determine whether f of x has an inverse function.
Is there even one?
So, very first thing, what do we need to do? Graph it. So go ahead and graph x cubed minus 16. X cubed minus 16. Okay, What you may need to do is open up your window. A good window to look in would maybe be from -10 to +10, and then from -40 to +40. So on the x's, I would go from -10 to +10 on your graph. And then on the y's, I would go from -40 to +40. Your y scale, I would probably go with a y scale of 4. Now in doing that, you're gonna get a little better picture, okay?
The intersection negative 16.
Okay, so now in looking at that, is that gonna have an inverse function? Does it pass the horizontal line test?
Does.
Yeah. Now for those of you thinking it doesn't when it goes, like right here, you think it passes at 2 points, it doesn't. That's just kind of one of those things that you need to understand about how that graph looks. Okay, any of those cubed graphs, you're never gonna have them intersect 2 points there. Okay, so now let's go ahead and find the inverse function. So the very first thing, what you're gonna do, step 1. I'm gonna write it this way. Replace f of x with y. That's the very first step. Because now we've got something that's a little bit easier to solve. So first step, write that. Second step, see what I did? I just interchanged. So basically this is when we switch the domain and the range around.
Since they equal the same thing.
So now what we're gonna do is, we always have functions y equals something. So I'm gonna solve this for y. So to solve this for y, get y all by itself, what are you gonna do first? Add 16. So I'm gonna add 16 to both sides. Now what do? We gotta take the cube root. So we end up having the cube root of x plus 16. Oh, not 16 equals y. And my final step, in place of y, I don't want that to be the case. I want it to be the inverse. So I'm going to go ahead and write that as f inverse of x.
So that is the inverse.
So very first step, you replace f of x with y. You switch x and y, solve for y, and then replace y with f inverse of x. So that's the inverse. Now what we need to do is do any restrictions on the domain. Okay? And so when I think about this original graph, what were the domain and the range? Yeah, the domain was like all reals, wasn't it? Everything, and the range was all reals. So what's going to happen is those are going to translate to this equation right here. Okay, and so are there any restrictions on the domain? Nope, there's not.
So domain is up and down and range is up.
Yep. No, the other one. Domain is left and right, range is up. Okay, I think we're running short on time, so I'm going to go ahead and stop, and we'll continue on with video